What's up, everyone, and welcome to another episode of the Fabricator series with yours truly. Now, this is not a trick, this is not a fancy camera angle. I am in a factory right-hand drive, and it is not my truck. Now, if you look behind me, you can see a really awesome looking roll cage. That roll cage is spec'd to Global Time Attack. Now, you might also be wondering, what kind of car that would be factory right-hand drive make a great time attack car? And I mean seriously awesome time attack car. Now, if you haven't figured it out by now, just by seeing what we've got, how about I pull up into the shop real quick and show you. Do you know how badly I wanted to run that intro? I'm the Fabricator, and I'm here to introduce to you part 1 of how to build a time attack roll cage. Now, as you probably guessed, if there's part 1, there's part 2, and this is a really long video, and you're absolutely right. Between parts 1 and 2, there is 3 hours worth of information and instruction about how to build a time attack roll cage. Step by step, tube by tube. Why and how. It's all there for you. The vehicle? Well, I'll tell you flat out. It is a 2000 Mitsubishi Lancer Evolution 6 RS TME. A real one. It's here in the States, and yes, it's better known as the Evo 6.5. There's a cool story in part 2 about how the owner acquired it and brought it back to the States. Said from the owner himself. So, there's a bit of a prequel to this video. It is how to notch tubes by hand, or how to notch tubes without the use of a tube notcher. You should definitely watch that, give it a good look over, and become well versed and understand how it's done and whatnot. And the reason why is because I don't go over a lot in this video and in part 2. You don't see me doing a lot of tube notching, but I do reference it a lot, so you should understand the vocabulary and the process in which the way it works. And absolutely, I mean, read it over so you can practice it and everything else like that too. In the event that you get pulled away, in each video there are chapters. There's 7 chapters in part 1, there are 8 chapters in part 2. In the description below, you'll see the time signatures for each one. So if you get pulled away and you've got to come back, you just click right onto one of those, and it'll take you right to the beginning of each chapter, and that'll help you find your place where you left off before. So definitely check down there on that. While you're in the description there, right next to my nice picture that's floating there, push that bright red subscribe button if you haven't done so yet. I appreciate it if you would. You can also follow along on Facebook. You go to facebook.com/thefabricatorseries. Push that like button for me when you get over there and let me know that you showed up. I really appreciate it. Instagram. I'm a big fan of Instagram. I post lots of pictures all the time. So between Facebook and Instagram, you'll always get the latest and greatest updates between the two of them. So if you head over to thefabricatorseries.com, that is the official website for everything that I do here. And if you look in the build blogs, you will find how to build a time attack roll cage. And in there you will find parts 1 and part 2 of the videos. You will also find pictures that I took along the way. Some of them made it up to the social media accounts. Some of them not. You'll find them only here on the blog, the build blog itself. So, better yet, if you scroll down just a little bit further, you will see something that put all of my work to shame. I hired a professional photographer to come in and shoot the entire thing. He absolutely captured the likeness of this cage and just phenomenally, and the pics look fantastic. You've got to get up there and check those out. And if you scroll down a little bit further, you'll find the gag reel. Now, that's every single time I botched a line, screwed up, dropped a tool, or my day just flat out wasn't going right. It's all up there. It's only going to be found there for you to watch, all in one place. And a little bit further down here, you can find the comments section where we might have a discussion going about each one of the parts. So if you want to ask a question, you can do so anonymously, or leave your information and I can address you directly. Either way I can respond, and I'll be happy to do so. You can also drop a comment in any one of the videos directly on YouTube there. I'll definitely do my best to get back to you. If you'd rather not post publicly, you can send me a private message on Facebook, on YouTube, you can DM me on Instagram, or you can email me directly on the fabricatorseries.com website. It's all very easy. I definitely do my best to get back to you. If you have any future suggestions for future episodes, please do drop me a line, and I will do my best to absolutely put together a little episode for you and see if I can help you out on that one. So that's about all I've got for the introduction of part 1. I really appreciate you being a part of the Fabricator series. Thanks for subscribing, thanks for jumping on, and thanks for all the great comments and everything that's on all the accounts and whatnot. I really do appreciate it. So without any further delay, here's how to build a time attack roll cage. So we're going to start with the main hoop. And the reason why we start with the main hoop is because every other tube is attached to it. So you can't really mock up, measure, bend, cut, weld, or anything, any other tube, unless your main hoop is in position. Okay? So there's a few things that you need to consider. Every single cage should be custom tailored to the driver. It's kind of like getting fitted for a suit. You know, they take all of those measurements and they get everything, and you put that thing on, and you're like, oh wow, that's dead on, you know, as opposed to just buying one off the rack saying, oh yeah, I think this is my measurement, right? You need to have the ultimate comfort, basically, okay? So during each race, if your driver is not comfortable, you're not going to have a really good race, okay? You want them to feel kind of at one with the car, and that's the whole purpose here. The goal is to get the cage to fit your driver, okay, not you, the builder, okay? So we'll talk about the driver for a minute. You need to know about the driver themselves, whether they're tall, whether they're really short, okay? Somebody who's a little bit shorter, the main hoop is going to be a little bit more forward on the car, versus somebody like me. I'm almost 6'3", so that main hoop's practically going to be in the back seat when I drive, and where my comfort level is and how I like to sit, okay? So that's one thing you need to note and remember, okay? The seat itself. Now, this seat is going to change, okay? We have a Sparkle circuit seat with a Hans device compatible that's going to go into it. If that's going to change up, then the position of the main hoop might, okay, and everything that's attached to it, right? The height of the seat, the position of the seat fore and aft, the angle or the layback degree of the seat also changes the position of the main hoop and the design of the main hoop, and this is all very, very important. So what I did before the driver left, when he dropped it off, we did an initial fit check. Now it is with this seat, and that's going to change, but that's something I have to keep in mind when I'm positioning this main hoop and when I'm measuring it out, okay? So once I get the main hoop in, we need to do a fit check with the new seat mocked up in place, and we'll figure out the position of the main hoop later. But for right now, we can get it measured, bent up, and set in place. In addition to all of that, certain other things will change the position of the main hoop later down the road. Everything is always subject to change. So as the driver may say right now, I've got the seat that I want, that is perfect, they might find one later on down the road that they, you know, that they're going to like a lot better, and that's going to have to go in here. Things about the steering wheel. Certain steering wheels will change, because if the driver's position now is here, and they put in, let's say, a deep dish, and it goes on here, closer to them, they might want to move the seat back a little bit, so you're going to have to give enough room for that. So as we're measuring all of this, we need to keep all of that in mind. The driver's equipment. This is also something that when you do your fit checks and you do your consultation with your driver, that you find out where and what they're going to be using. Okay, things like a Hans device, their helmet, the type of helmet, the height of the helmet versus where they're sitting, and everything else like that changes the position of the main hoop. And this is definitely something you need to keep in mind. So with all of that in mind, the driver's going to come in for his fit check in all of his gear. Okay, but in the meantime, we can identify our tolerance, and we can start bending up our main hoop, okay? And that later on when we do the fit check and he comes in all of his gear, we'll identify or place the roll cage in the correct position, okay? So I'm gonna start with the tolerance. Now in a completely stripped out car like this, the tolerance is, you know, I like a nice form-fitting cage, so I'm gonna give myself less of a tolerance. Now the tolerance is gonna be the space between the outermost point of the tube and the chassis itself, okay? In completely stripped out cars like this, I give myself a tolerance of about 1 inch. And that 1 inch translates to a ½ an inch on each side. Okay, that allows tech officials to get their mirrors and their inspection spots and whatnot so they can check the tubes to do as they need. Okay, some cars I can actually maintain as much as a ½ inch, which leaves a ¼ inch on each side of clearance, of tolerance. So for this build, I'm going to try and maintain a point somewhere between a ½ and a ¼ inch of clearance on each end. Okay, so whatever measurement we have, we're going to subtract our tolerance. Okay, so I'm just going to notate in the beginning here that I want to try and maintain a tolerance of ½ an inch. Okay, so each time I'm going to add or subtract an inch to it, and that'll give us a pretty good tolerance. Okay, so now we can finally measure the roll cage, and this is where we get to all the fun stuff. You only need a handful of tools, and you'll need to write all your measurements down. So I use kind of a generic form that I make. It has the outline of a roll cage, has our 4 angles that need to be bent. 9 times out of 10 they're going to be identical on both sides, but I have all 4 of them listed. The start points of each bend, okay, those are also listed on here. The center line, our datum lines, and our height and width, which is all part of the datum lines. Okay, so to measure out, you don't really need a whole lot of tools or anything extremely fancy. You need some form of a marker to mark on your chassis. To mark on the chassis, I use tape, and the reason why I just put a line of tape down and mark on that is because it's kind of rude and tacky to just start scribbling all over your client's car. You know, once the cage is all in here, they probably don't want to see a whole bunch of lines and measurements and scribbles and stuff like that, so use tape. You can also peel it off and put it back on a new piece in case you screw up your measurement or whatever the case is. You can write anything you want on it, it's not going to go through to the chassis. You need some form of an angle finder, or protractor is what they are. I like to use the magnetic base ones because they just kind of stick there and they tell me exactly what I need. You can use the other type of angle finders or protractors. You know, you just stick it up there, kind of stick it in place where you want it, tells you the angle right out. Doesn't matter which one. You need your tape measure, and you'll need the cheater. Now the cheater is the bar that we're going to use. It's already bent up. It has the same center line radius of the roll cage that we're going to be doing here. It's also made out of the same material that we're going to build the roll cage out of, which in this case is 1.5" DOM. The start of the bend has a notch cut out in it, and this is very nice because I can stick the tape measure in there when I place it and run my lines accordingly, and I know where the start of each bend is, and that's going to give me my measurement. Alright, so we're going to start with the datum point. And the datum point, or the datum line, is the base of which we're going to start from. So datum is just kind of a fancy way of saying start, or base, okay? So there's something very imperative that you need to remember here, okay? And that is, once the cage is all mocked up and in place and whatnot, you have to be able to weld the top of it, okay? So if you maintain a tolerance of, you know, a 1/2 inch or a 1/4 inch, you can't get the welder in there to actually to run a bead on it. So there's a couple of ways that we do this, or that we work around that. One of them is to build a rocker box, and the rocker box will elevate the cage off of the floor. And when you go to weld the top of it, you remove the rocker box, the cage drops down, and then you can weld the top of it. The other option is to cut holes in the floor, and then once it's time, again, you'll drop the cage through the floor and you'll be able to weld the top of it, put it back up, plate the bottom of it, and there's your mounting point. So in this case, on this chassis, I'm going to build rocker boxes. So the top of the rocker box will be the base, or the beginning, or the datum line. Okay, that's what we got to measure out for right now. So you need to make sure that your width is compensatory with the rocker box. So in this case, the rocker panels kind of angle inward slightly at about 10 degrees. So we're not going to measure the floor. We're actually going to measure the height of which the rocker box is going to be at, or the point at which the rocker box is going to be. So I'm going to look for a couple of symmetrical points, which I found both here at the inlet of the door, or the door jamb right here on this pinch weld, or this seam. Same thing on this side. It's the same thing on both sides. So what I'm going to do is measure that. Looks like I got 55 inches. So my datum width is 55 inches. Now we're going to need to compensate for the rocker boxes when we measure out our height. So there's some extra stamping in the floor here, and it's kind of uneven. So when we go for our height measurement, we're going to need to subtract the height of the rocker box. So how tall is that going to be from the floor? I just take my protractor, I'll stick it on the edge there at about what the height of the rocker box is going to be, look at it while it's at 0 degrees, and then take a measurement to the edge of it, which looks like I'll have a 6-inch rocker box. Okay, so when we measure our height, rocker box 6 inches. When we measure up our height, we'll subtract 6 inches, and that'll be our datum height, which we've got to this rib, 47 inches. So we subtract a 6-inch rocker box, and we got 41-inch datum height. 41. So inside that area, 55 inches wide by 41 inches tall, that's going to be the area that our main hoop is going to be built into. Okay, so all we need to do is find out where our halfway point is, and we'll start from there. You know, we'll calculate all of our angles and figure out where they're going to be. The easiest way that I've found to do this over the years, rather than calculating the point, start and stop point of every single bend, is to actually start from the very center of the top of the main hoop and work our way down, okay, on both sides. So in order to do that, we're going to need to figure out where the center line of this is, okay? So we're going to pick 2 points, just the same as we did down below. We're going to pick 2 points and find the center of that. And it looks like I've got a distance width of 38 inches, okay? So half of 38 is going to be 19 inches. piece of tape right down the middle. Go 19 inches. Now, just to make sure I'm not going crazy, I'm going to measure from this side. Got 19 inches as well, so I'm going to fatten that line up just a little bit so I can see it a little bit better. Okay. Now we're going to take our cheater. Just kind of place it up here, and I'll even stick it right up against there because we've got our tolerance that we'll end up subtracting. And I can see the point where I need to put another piece of tape. Right about here. Okay. Now let's put this back up again, and right where the notch is, we'll make another mark. I'm going to do the same thing on this side as well. Now let's take a measurement. Looks like 14 there. 14 there. So 14 inches on the start, or from the center line to the start of each bend. I'm going to notate that. Start 14, 14. Okay, so we can't forget that we have a tolerance that we have to take care of here too. And what I did is I wrote down the exact dimensions as they were measured, and then I'll calculate the tolerance later. The reason why I do it that way is in case I want to go back and change up the amount of tolerance that I have on it. I don't have to worry about remembering or anything like that. So we put down the exact dimensions as they measure on the chassis, and then we'll go back and subtract the tolerance later. So now we need to figure out what point or what degree of bend we need to add into the tubes on the main hoop. So we already know exactly where they start, we just don't know what the degree or what angle they need to sit at. So what I'm going to do is take the protractor, we're going to stick it on here. Looks like we've got a 65 degrees is where that sits at. So I'm going to take a piece of tape here and say 65 degrees. That's the first bend. Next we need to figure out at what point to calculate where our second bend is, at what point the B-pillar actually starts bending back inward and starts transitioning into that angle from being perpendicular to the floor or to our datum point. So right about there. We'll take another piece of tape here, grab our marker, see if we can find that line again. Right about there. So if this was 65 degrees, we automatically know that the difference between 65 degrees and 90 degrees is going to be our second bend here. So what I want to do is actually figure out at what point it's going to start. We'll measure from the datum line to the line where it starts, the transition begins. That's 21.5 inches. So the start of our first bend from the datum point is going to be 21.5 inches. We already know our angle up top is 65 degrees. And the angle right here, since this is going to make 90, is going to be 25 degrees. So I have all of that filled in. The opposite side should be exactly the same, but what I'm going to do is play safety on this one because you don't want to go about throwing materials away after you bend the main hoop wrong. I'm going to go and measure this side out and make sure that it's exactly the same. Then we're going to get to bending some tubes. Just a quick cleaning of the tube. I make sure I clean each and individual one of them before they go in because, well, I mean, you have less contaminants that way on your weld, and of course, it's a lot easier to clean before you bend it while it's on the outside of the car as opposed to when it's in the car. So, first we're going to figure out where the center of this tube is. Now, there's kind of a little bit of not really a trick here, but just something for you to know. The average main hoop is 10 to 12 feet long, total from start to finish. That's the average of which everything fits in there. This one's going to come out just shy of 11 feet by the time it's from the datum point all the way back around to the datum point. So I have a 12-foot tube. This is what I'm going to start with. We'll measure out halfway. Now I like a big, fat, bright identifying line as my center point. So I got this bright red marker. I'll measure it at 72 inches, which is 6 feet, which is half of this tube. Now, according to our form here, from the center line to the beginning of the first bend is 14 inches. Now, that's the exact measurement. So if we were to bend it up right now as it is, it's going to be smacking the side of the car. We don't want that. We need to subtract our tolerance, okay? So from each side, I want a tolerance of a ½ inch on each side. So we're going to go from that center line, which we measured at 14 inches, subtract our tolerance, we're going to go from that center line to 13½ inches. That's the start of the first bend. We'll go 13½ again. Start of the second bend. With this, we're going to throw it into the bender and start our first bend. Okay, now this line here signifies the beginning of the bend, okay, and that's going to go right up against this die right here. So we want it pretty much right on there as the start of the bend. Now we notated exactly where it's got to sit at, and we know that the start of each bend was the inside of the bend. So those marks that we laid out and the marks that we measured here on the tube is the beginning of the bend, or it's going to go on the outside. So you got to make sure that your center line is here, the beginning of your bend there, the bend is going to be on this side of the tube where it needs to be. Okay? So with it lined up on the die, right at the beginning, we're going to crank this down nice and tight, make sure it didn't move. Now every bender is a little bit different. And these ones, they have to preload them just a little bit before you set the dial. So I'm going to set this up right on 0. Now the first bend that we needed was 65 degrees. So that's what we're going to load onto this one. Now spring back is one of those things that you kind of need to prepare and compensate for while you're bending. So what it basically is you'll pull the bender, and it'll go all the way up to that gauge, like where it says, like in this case, 65 degrees, and as soon as you let off, the needle will back off, and at the point where that sits is the spring back, or the point at which the spring back affects it. It's usually a few degrees. In this case, it's about 5. So what you need to do, as soon as you hit that point where it springs back, you'll just want to slowly just inch it toward the point where it rests right about 65 degrees, or at the angle in which you need to bend it. And that'll compensate for the spring back. So we got the first bend to finish up. This next step is extremely crucial. And the reason why is if you have this off or on a different plane, it's going to bend your main hoop crooked. So one leg will be this way, the other one will be that way. You don't want a crooked main hoop. It's tacky, it means you were in a rush, and you want to double check and make sure that you got everything just right. So I'm going to set the protractor up on the die. The die reads exactly 0 degrees. Okay, so we're going to put it over on the top of our main hoop. That reads exactly 0 degrees. We're going to put it over on the leg. That also reads exactly 0 degrees. Okay, so at this point where we crank it down, we know we're good to give it a bend. Now, over here I have a leg that's already set up. Okay, or this support that's set up, and the tube's going to bend right along this until it's at the point where it's not going to deform or get out of whack. So you can shim this accordingly. If you don't have the right amount of angle, or you have too much angle in one or the other, you can always shim this side or drop it down, or whatever the case is, to make sure that you get the right angle on it. So now that we have it set up, I'm going to preload, set my dial to 0, Now we're ready for the other 65 degrees. So I've already set this up using the measurements that we took earlier from the car. So I use the table kind of as a mock-up jig replacement for exactly where each measurement, each mark needs to be. So in this case, I just use some flat tubular steel. Looks like 1x2, I believe, is what I have laying around. I just lay it all out there. Now you'll probably notice my table's a little wobbly here, so you just kind of ignore that part. But our base, our datum line has already been set up with this lower tube. So at this point, from the top of the main hoop to the top portion of this tube here, or this base tube, is our datum point, okay? So it's 41 inches from here to the datum line. Now I'm not going to subtract the tolerance for it, just because we don't exactly know where the rocker box is going to sit, and I'm not going to fabricate those right now. So from the datum point to this tube here, the top of this tube is 21.5 inches. 21.5 inches was the beginning of that bend, or at least the point in the V pillar where it started to transition into the bend, okay? So I've also marked out the halfway point from here, the center line, which is in reference to the top here. The center line is also on this, on the bend line, or at least the bend reference, okay? So to measure out where everything needs to be, or to find out where it needs to sit, we take half of 55 inches, which is our datum width. Half of 55 inches is 27.5, and we're going to subtract that half an inch for tolerance, and we're going to measure outward 27 inches. So from our center line, 27 inches on the outside, 27 inches on this side. Both of these have already been measured out. So what we're going to do is kind of take our cheater here, and we're going to eyeball it. I'm going to place it directly on top of the tube, and I'm going to look, kind of figure out about where that bend is going to land, okay? This is entirely up to your eyeballs, but you want to make sure that you, if anything, come in just a little bit under as opposed to over. So where I have it marked out, where I have it land, okay, I've taken a marker and marked out where the beginning of the bend is going to be, okay? What I did was translate that to the opposite side. Okay, I don't want to rely on my eyeballs twice, I'll only do it once. And since this tube was measured out and started from exactly halfway, then it's going to be the same measurement on both sides. So I measured up, I got 36 and 5/16 of an inch. Okay, so what I did was translate that to this side. 36 and 5/16 of an inch. Okay, both sides are ready to be bent. Now what I'm going to do, so I don't end up forgetting, is after I kind of highlight these lines here, I'm going to note which side the bend needs to be on. And that's very important. Because if you bend it in the wrong spot, you just trash the entire main hoop. That's kind of expensive. It's also time consuming. So, to recap, if you want to go over this again, go ahead and just rewind it a little bit and go back over everything that I just did. So I'm going to pull this off, set it back up in the bender again, and we're going to get our last two bends in here, and then we'll figure out how to trim to our data point. So just like before, if you fail to measure this out and place it correctly at 0 degrees, you will have a crooked main hoop. So I've got it all set up again, preloaded, dials on 0. This angle is 25 degrees. Okay. Looks like we've got some great tolerance in there. So I don't want to trim off exactly at the datum line. And the reason why I don't want to trim right off at the datum point is because I'm not quite ready to fabricate the rocker boxes. So, remember we compensated for it 6 inches for our rocker boxes. So I'm actually going to start with trimming off about 5 below the datum line. Remember, at the end of the day, you can always take metal off, but you can't necessarily put it back on. So at 5 inches, I'm going to trim those legs off, and then we get our first fit check. Section 4.6.7 in the GTA CCR 2015 rules states that you need one diagonal brace going from the lowest point, which is going to be our datum point, to the top, right above the driver's head. So that point is going to span, of course, diagonally from here to here. Okay? This has to be in there, and it can't be modified, cut, distorted, or anything like that. But also, in the rule book, down a little further in 4.6.17, that says that you can add additional bracing. So what we're going to do is form the X brace. The X brace is going to start with our main brace. Since this is right-hand drive, it's going to go from the bottom left of the car to the top right of the car. It states that it has to be within 12 inches, but we're not going to go anywhere near that because that's going to be right about here. We don't need that kind of clearance with our driver. So the second brace is going to go, and this is going to be cut in half, from the bottom right of the datum point up to the same point just past the bend on the left side. Okay. So first we already started out here. I already took the liberty of measuring this. And this is an overcut measurement, or an over measure. We got 56 inches. So I already cut the tube and had it ready. So that's just to save a little bit of video space here. So there's not really a need to shoot a bunch of video of me slice the tubes up. So if you don't really know how to cut a tube up, then then you probably shouldn't be doing this. So just like in the tube notching video, I'm going to make my face line. I'm going to make my throat line. I'm going to feed this one into the saw here, and we're going to find out how close we are on that one, and then we'll go measure and cut that one. So to kind of help me mock up here, I just use some vice grips. They hold the tube in quite well when you're measuring, mocking up, getting ready to weld, or even tacking it all together. So, alright, looks like I got a great fit. So first I'm going to clean these tubes up a little bit. Get a nice clean weld. So I'm not going to use anything more than just a prep pad, or something we call it a Scotch-Brite by the brand. We'll clean both of these ends up extremely well. Nice, clean, fresh metal. At the same time, I also have my tungsten, my TIG welder sharpened and cleaned up and ready to go. So as soon as I get both of these sides cleaned up, start laying down the tacks on this one and get it all set in place. And just remember, we're only going to tack weld. And the reason why is because if we need to change it later, and we discover that during the fit check and whatnot, then it's better to break down just a tack weld as opposed to an entire weld or having to rebend the whole main hoop all over again. So just to be on the safe side, we're only going to do tacks on this one. Set this up again. I'm going to use this straight edge here to kind of guide and figure out where exactly the line is and where the center of this is, because this section here has to be two separate tubes and they have to be completely in line and they have to match this tube. Okay, so to recap here, this diagonal brace has to be unmodified. Okay, it cannot be cut in half, it cannot be bent, it cannot be anything except for one solid piece all the way from one corner to the other one. So the second one that we're adding in here is considered additional reinforcement as per the rules. We're allowed to have additional reinforcement, but this piece itself has to be two separate pieces. It can't cut the main. You can only cut the two separate pieces. So to make sure that we get them in line, I'm going to use this straight edge here. I'm going to try and place it here at both ends. And the idea here is to get the inside of your tube or your straight edge to mate up with the inside of this line on the inside of the tube where the actual tube itself is going to mate. So you just got to kind of stare straight down at it and get that right there and not move. Evenly, and then we're going to mark out the center. Now I'm only going to mark out one section of the center as my guide. Okay, so I'm going to start at the top. Okay, you can start at the bottom, it doesn't really make a difference which one you do, but we're going to start at the top piece in a small pre-cut section. And just like in the tube notching video, create the face line and then the throat line. So I'm going to go ahead and cut this piece, and then when we fit that in, I'll go back and do this one at the same time. Alright. That notch is nicely fit. Run the inside of the tube matches up with that line, the inside line that we have here, to make sure that this stays the same on both sides. So we go our face line, and then our throat line. Now we'll go notch that out. Hopefully we get it right on the first try. Let's slap this in. So again, we're just going to run with the tack weld right now and not the full weld. We'll get the full weld later on after we get everything all lined up. So let's just start with the tack. Okay, so it's a lot easier working with a smaller tube, so we've already measured this one out. We're about the center of that diagonal brace there to the edge here. It's about 37, 38 inches, somewhere in there. So I've already cut and cleaned the tube. So we're just going to set it up, kind of use our eyes here to get it in line. And I'm going to start at the lower corner here. This is an easier notch to create. Okay, so we'll set this up again just like the tube notch video. Create my face line. Now this side of the notch, I'm not obviously going to put a throat line on there because I'm going to try to utilize this section of it. It's going to mate to the tube when I make this cut. But this throat line, we're going to make that. Get it kind of roughly clamped. I'm going to use my eyeballs here to kind of set it up right. And we'll get to this section. So, rule of thumb applies, 1/3 tube diameter, just like in the tube notch video. And we'll make the face line. Get the throat line, the other throat line, and we'll cut that out. Alright. Number 2. So I'm just going to toss this in here, just throw it in kind of loosely for the moment. This is a very important measurement that we have to make sure that we maintain on this one, and that is our datum width. So as we mentioned before, we have our datum width of no more than 55 inches. So with this all put together, we need to make sure that we're within that 55-inch collar, or that 55-inch width. But don't forget, at the same time, we still have the tolerance of a 1/2 inch. So our datum width is going to be no more than 54 inches. And right now, I'm at 53 7/8 of an inch. So we're good. Now, if your datum did come in just slightly over, you're going to have to tweak your main hoop in, which you can take some straps, or you can take, just about anything you've got to make sure you pull it in together a little bit. But remember, if you do that, that's going to knock this angle out. So make sure that if you have your datum width already set in there, that you go back and you probably have to make some adjustments to your other tubes. So since we didn't warp or get out of dimension at all, this tube's ready to go in here. So I'm going to make sure that I line this up almost perfectly, right where it needs to be. There's almost nothing looks worse than a crooked tube. And we can lay down our tacks. So with only a tack weld on that side, we do have some wiggle room here, and that allows us to get our tube just right where it needs to be. So I'm going to finish sure that this lines up. Okay, well, I've got the main hoop back in place. The driver's already come through for his fit check. Now, the initial fit checks, they take roughly an hour to do, and I need to focus more on the driver and less on the camera. So, I don't have that on video, and it's not going to be added to this. But a few things that I'm going to go over here is, one, I use the absolute most sophisticated seat placement system available on the market today. And basically all I do is set the boards in, and it moves the seat up or down, fore and aft, and also takes care of the layback. Now the driver has to be in full upper gear while you do this. So things like the Hans device, if they have one, a helmet, those are all very important things that they need to have, and you need to make sure that on your initial fit check and many other ones that your driver is in full upper restraints and basically getting measured to how they're going to be in the vehicle. Okay. Now, one very important thing: take as much time as you like with your driver. Okay, because they got to experience and get the comfort of all kinds of different placements, and they can't always just drive around the block and say yes, I like this, or no, I don't, because everything's all loose and just kind of sitting here. So take lots of time with them and let them really feel where they're at, and if they like the the placement of it, and go over a few different options, explain a few different things for them. So I did get the main hoop completely welded. It's now back in, set in the right place according to driver position, and now we're going to work on the harness bar. Okay, so most rules state on the harness bar, or at least on the restraint system. They don't usually say always on the harness bar portion of the rule book itself. Quite often they actually put the rule and the listing in the section about the harnesses that you use and their amount of degree of angle that they're typically allowed to be mounted at. Now, most systems will say anywhere between 10 and like 30 degrees, for example, or the average is about 10 to 15 degrees. So GTA CCR specifies under the harness parts, or under the harness section, no more than 30 degrees, while the local sanction, or the lesser sanction, I guess if you will, is red line time attack, RTA, they say no more than 25. So I'm going to go for a range of 10 to 15, and that's where I'm going to place the harness bar. So I just take a piece of flat stock with my protractor on it, and I'll measure up roughly where we're sitting. And the reason why I go slightly under is because if the driver ever wants to change position, it doesn't change, it doesn't knock them out of the rules, essentially. So you also got to remember that not every time you got this big section of hole here, and the Hans system and the Hans device and their shoulders, or whatever the case is, also changes the position. So if you go about halfway up this hole here and measure downward, and then from the bottom of the seat itself, you'll get your range of harnesses. So right about here I've got 10 degrees. If we go up to the top, I've got 30. So either way we slice it for GTA, will be still within the rule book. So at the 10 degree mark, I'm going to mark the center section of the tube. And I'm going to measure from the bottom to my mark. I've got 23.25 to the center of the tube. So now we're going to pull the main hoop back out, start welding the harness. So we measured it up in the car, and we got 23¼ inches from the base of the main hoop. So I'm going to duplicate that measurement on the left side, 23¼ I'm going to take a straight edge, kind of line it up on both sides evenly. And then mark out the centers for the center section of the harness bar. Now we'll take our measurements, and this is just kind of eyeballing it, rough guesstimate. Looks like I got about 21 inches. Of course, the other side should be 21 the same. Center section is about 10 inches. So I've already cleaned up these tubes, or these points where they're going to mount. and I've already cut the tubes. So let's start with the driver's side here. And of course, just like the tube notch video, I've said it a dozen times over already. Line this up. I'll do my face line, and then my throat line. Now I'll go trim this one out, and then see how close we get. Now just remember which marks you are, what you've already made, or the marks that you've already made and what they represent. So in this case, these are actually my center lines, so they're made up with the face line of each tube. So just remember that. Otherwise, your harness bar could be knocked out by at least anywhere between 5 and 10 degrees. Which, if you get that wrong, you pretty much got to start over. Okay, we got all the tubes cut, notched, cleaned up, and we're ready to start welding them all in. So, of course, in the beginning, just like all of these, you don't want to lay out a whole bunch of weld right off the get-go in case you have to make some adjustments, trim it up, whatever the case is. So, just like usual, we're just going to drop some tack welds on here, and we'll go back and measure it all. Okay, well, we have the main hoop in. I already finished up welding everything, and I added this gusset to it, and later there's going to be a taco gusset on here. Now, I did just roll through these, and there will be a segment a little bit later on in the video about how to build the gussets. We'll go over all that. Now, with the main hoop complete, we can start working on the forward hoops. We're going to go over that right now. Okay, so now we're going to get to fabricating the forward system, or the front hoops, or the forward hoops, or the front section, whichever one you want to use as far as terminology is concerned, as long as we're talking about this area up front forward of the main hoop. Now, fabricating these is not that difficult to do, or even measuring and bending them is pretty simple too, compared to like the main hoop, for example. That was probably one of the hardest pieces to make. So there are a few things that you need to pay attention to, though. Now, you're going to pay attention to the type of racing or the class of racing or sanction that you're running with, and that you are within their design parameters and what they allow and do not allow for use on the forward system. So in the case of GTA and RTA, there are 3 different designs that we're allowed to use. The first one is using 2 separate forward hoops. They start at the main hoop, run along the roof line, down the A-pillars, and then down to the floor. There's one on each side with a windshield bar connecting the 2 of them. The second one's called a halo system. The halo system starts at the main hoop, runs along the roof line, goes across the windshield, back along the roof line, and connects again to the other side of the main hoop. Then there are 2 separate tubes that run down the A-pillar and then down to the floor. The third one is called a forward hoop, or a front hoop, and that starts at the floor, runs along the A-pillar, goes across the windshield, back down the A-pillar, and then down to the floor again. It's very rare that I use a front hoop, okay? And the reason why is because at the radius of the bend, when it gets up to the top here, can, and often sometimes does, obstruct the driver's field of view. I don't care to use that very much. So the other option here, or the other reason why, is because oftentimes you have a small car like this, or a semi-complicated chassis to work with. It makes it very difficult to get the entire hoop in here, slid into through the dash and whatnot, and get it all set up and made correctly or fit correctly. So you take the chance of damaging the dash and whatnot, and that's not something I usually like to take the chance of doing. The halo system I use frequently, not as frequently as the first system mentioned, but the halo system comes in handy when you have a difficult angle to achieve, or you're going to put too many bends in your forward hoops. So the design basically, if you have a roof line that is a very streamlined design, and the roof line actually goes upward a little bit or bends upward before it goes down the A-pillars, then usually you want to run the halo design to ease your fabrication and make it a lot quicker and whatnot. So I don't use it very much, but I've used it before, and that's it's kind of the only way to get around that really streamlined design. So this one is going to use just the 2 separate forward hoops. It's pretty much the easiest thing to do, and I like the design better, and there's less obstruction of the driver's field of view. So in order to do that, to get set up, we're going to find out roughly how much material we need. So I'm going to start by measuring from the main hoop to roughly where the first bend needs to be. That's about 2 feet. We'll measure to the second section here, about 4 feet. We'll measure from the floor to roughly where that one was before. We're at 27 inches, so 2 feet 3 inches. Now I need to figure out roughly where the first bend is going to land. So I'm just going to use some tape and a marker here. And I recall where that first 2-foot mark was. And I'm going to guess, and somewhere about in here is about 12 inches away. We'll put another piece of tape right there. Because half of 6 feet is 3 feet, or 36 inches. And I mentioned before, it's a lot easier to work from the center of the tube outward to get your bends, or at least a bend in a tube where you only have 2 separate bends. In this case, it'll be a lot easier. So I'm going to give just a little bit of excess and start on the outside of the main hoop on my measurement. With a 24-inch mark, about right there. And we're going to add 12 inches to it. And right here is the center of our 6-foot tube. So first I'm going to place the cheater bar with the notch on the inside indicating the beginning of the bend. Make sure that faces the center of the tube, which is this mark right here. Now I'm just going to kind of eyeball this to say about where I want my bend to go. And I'm going to have the bend go kind of high and tuck it up in here to keep it out of the way of the driver's head, because we don't want any contact with the driver. So I'd like it to start up here, and we'll make it reach up to the main hoop there. And that actually lands right where my 24-inch mark is. So I'm going to make the start of the bend at 24 inches, or 12 inches from the center, and leave 24 inches to go to the main hoop. So that one's actually pretty easy. So that'll be the start of the first bend. Now we're going to set this up and kind of eyeball it again to the area where it's going to pass through the dash. And make sure that you give yourself enough wiggle room in there. And I'm going to take the tape measure here. And from the beginning of the bend to the center tube mark, looks like 8 inches. So we got 8 inches from the center to the downward bend that goes through the dash, and 12 inches from the center to the upward bend where it heads to the main hoop. Those 2 measurements, that's all we need to know right now, except for the angles. We need to know what degree they need to be bent at. So if you notice here, the roof line does kind of gradually slope down just a little bit, so that we need to figure out what angle that sits at. So I'm going to place the protractor up here, and that looks about 10 degrees, and then we need to find out what angle the A-pillar sits at. That angle rests at 30 degrees. So what we're going to do is take 30-degree angle here, subtract the 10-degree angle here, and this first bend is going to be 20 degrees. Okay. Now, since the position of the lower section of the tube is going to be actually offset or further outward than the upper section, or where it meets the main hoop, we have to calculate and figure out the offset bend. Now, offset, to easily explain this, is if you look at your A-pillar at this angle where I'm at right here, you'll notice that it comes inward only slightly. Now, that creates an offset. What that means is when the tube comes down, it has to bend at the correct 20-degree angle here, but also needs to go slightly outward. And instead of putting 2 separate bends in there, we're just going to put one, and we're going to offset the second bend to go in the direction that it needs to go in. So, first we need to figure out what that's going to be. Now the best way to do this is to take your protractor, hold it at 90 degrees, and then turn it inward to the point where it just starts touching the A-pillar. And now we have a 10-degree offset. So we'll notice that when we set it up, and if we hold the tube perfectly straight, we'll see that it's going to bend inward and then bend straight back toward the main hoop. That's going to be the offset. So we know that this is 20 degrees up here. We know we have a 10-degree offset, and since the lower section of the tube has to be parallel with the main hoop, in a perfect world we'd have a 70-degree bend that goes down through the dashboard. I need a little bit of wiggle room. We need to have a bit of placement, change of design, whatever the case is. So I'm going to go a little bit less than the 70-degree mark. I'm going to actually start at 60 degrees. Because with the marking on the tube, we can always bend it a little bit further if we need to, but you can't unbend a bend. So to be on the safe side, we're going to start with 60 degrees down here, 20 degrees up here, 10-degree offset, 6-foot tube. Let's get to cutting. Okay, so we're using the same material as we did before, which is the 1.5" 120 wall DOM. As the rule states, it all must be the same. This is a 12-foot stick that I already had cut down when I purchased the tubing. And we're going to cut it right at 6 feet. So that means this one tube right here will service both sides. So we'll just get this cut out real quick. So I've already cut both tubes. They're both 6 feet long, and usually I would mark them out both the same since they're going to be identical on both sides. The only difference is going to be the offset angle when we feed it into the bender, and I'll show you that in just a second. But for the purpose of simplifying everything, I'm just going to mark this one tube here. Now, again, you can mark both of them at the exact same time if you're excellent with multitasking. So the center of the tube, 6 feet, is 36 inches, or 3 feet. And the first bend that goes up toward the main hoop was 12 inches away from that. So I'm going to mark this 48 inches. And we know this bend was 20 degrees. We'll write that down. Now the other bend toward the bottom was 8 inches away from the center of the tube. So we go down to 28 inches. Mark this out. Remember I said I wanted just a little bit less of a bend on it, so I'm going to mark this down as 60 degrees instead of the 70 degrees that we need before. And I'll show you probably why that's going to end up needing to be that way in just a moment. So now that we get these marks out, let's feed this into the bender. Once again, I'm going to line this up with this beginning of my bend, that initial bending line mark that we put in there. Set that up correctly right at the start of the die. I'm going to crank this down. Now this one is at 70 degrees. That's the bend that we need to make, so crank it up to 70. Now let's figure out our offsetting. So what we've done so far is we've thrown it into the die, set the marking up exactly where it needs to be, and I've tightened it down just enough to give me a little bit of twisting and turning room here, okay? So don't get yourself too wrapped up about this and try to figure out which way it's got to go, because you know one tube is going to have to bend left and the other one's going to have to bend right. So that translates to this leg's going to be up or this leg's either going to be down. Now you can sit there and try to figure it out, which I have, and I know that this tube, in order for it to fit on the right side, is going to have to bend downward because the bend starting from the bottom is going to bend left. That translates to down inside the die. So let's set this up, bent downward, which means it's going to bend left, and set that at 10 degrees. Okay. Now you also want to make sure that your die is set up correctly and you are reading 0 degrees, in which this case I am. So I'm going to double check again, make sure I'm on 10 degrees, crank it down, check again just to make sure, and really tighten it. I'm also going to double check that I'm still on my line at the die, which I am. So now we crank it down. Alright, now we've set up the passenger side tube, which in this case, if it was a left-hand drive, it would be your driver's side. Well, I'll just call it the left side tube. So remember the right side tube, we ended up bending downward to compensate for our offset angle. So this being the opposite side, this one's going to have to go upward. So twist it, set at 10 degrees, crank that down. Now of course again I'm going to check, make sure that my line is still on the die, which again it is. Check that I'm on 0, which I am, 10 degrees there. We're good to go. Now this is a correctly bent offset tube. Notice how the base of it is actually more towards the right than the left of it as you're looking down the tube. That is an offset angle. I've thought long and hard about how I'm going to approach this one. And the reason why is because I know a lot of the purists are going to start jumping onto the comments box there and going nuts on me, because this is a legit, real Evo 6 RS TME. And about ready to take a saw to it. So to clearly explain real quick, this is exactly what's going to happen. The tube has to go in through the dash, through the AC vent section, and at this point right here it's getting in the way. So it has to go away. And the only way to make it go away is to use one of these. The rule book says that all of the pieces, panels, dash, door cards, center console, all those must remain intact unless they interfere with the installation. So you can modify any one of those pieces aforementioned to facilitate the installation of the roll cage, which is exactly what I'm going to do. So if you are one of those purists, you know, hey, I'm sorry, but race car. We'll take a moment of silence. Alright, I gotta go to the other side. So now I'm just kind of positioning the main hoop here. I did drop it down so I can slide the tube above it and I can make my marks for the notching. So what I'm trying to do here is make sure that I have it smartly aligned with this upper roof rib that I said I was gonna made it up to earlier, and that's what we're basing all of our measurements off of. So I just use one of the holding magnets here and kind of get it in place. You want to make sure that both sides match up evenly, and that they're both even on the floor as well. Sometimes this takes a little bit of just kind of encouragement to get it to line up correctly. So now that I've got it roughly where it needs to be, I'm going to go grab another tube and we're going to feed it over there and start making our marks. Okay, so this really is just kind of a guess. You got to loosely eyeball it to see where you're going with it, but take our marker. I'm going to make my face line. And then we'll have our throat lines. Now we'll go make our cuts. All right. Front bars are in place. So here's the thing. One thing you have to note when you actually place your bars up top is how you're going to weld them as soon as it's time to completely weld all the way around. You might notice that the torch isn't going to really fit back there. So positioning of the bars on the main hoop is actually very, very important. And it is the case when you remove the blocks. Right now I have some wood holding everything up in place. When you remove those blocks, the cage has to drop down, and that's how you'll access those areas to weld them. So in this case, I have a 4-inch block below, so if I drop this 4 inches, I'll be able to access it right here in the door jamb. So just for future reference there, so you know. What I'm going to do now is put down as much weld as possible on these tubes, and then we're going to start fabricating the windshield bar and of course the roof bar. So. Okay, so now it's time for the windshield bar. And you know what, there's a couple of different ways that you can do this, pretty common. You pretty much kind of think about your driver's field of view. So in some instances you need it kind of sit high or tucked away, or even in other instances you need it kind of pushed forward, like just under the windshield itself. So to increase the structural rigidity of this cage and of course the safety of it, I'm going to put it right underneath this roof rib right here, because you know when this impacts all of this coming in, if it ever flip it over on its noggin, this will also help in conjunction with the bar itself to keep the driver safe. So at the point where it's going to sit, it's not going to be in the driver's field of view, so we can, you know, run with a very simple design and just run straight across. So I think that's the one I'm going to do here. Every now and again, if the forward hoops sit a little bit low, then we'll put a little bend on each end of it to try and mate up with it to keep it out of the driver's field of view. But again, he's sitting pretty low in this one, so I'm just going to run straight across. I'll take a measurement here, and the tube looks like I've cut a 38-inch tube, notched on both sides, and then we'll have a windshield bar. It's really that easy. So again, sometimes the simplest designs are the ones that you got to use. Let's see how we go. Well, I got the notches fit nicely, but you know what? Now that I look at this, I'm noticing something I don't like. And while right here, it would be theoretically out of the driver's field of view, I really don't like how low this goes. You know, I just can't let that slide. So, I think what I'm going to do is put a bend, an upward bend in this. Maybe we can try to revive this tube. It's pretty tightly fit, but you know, a small bend, it won't move it too much. So I'm going to attempt to revive this tube before cutting another one. So this is one of those classic examples where it starts out looking great, but sometimes in the end, you know, it just happens. So I'm going to take half of this tube, and I know the offset of let's say a 15-degree bend is going to be about 1 3/8 from my center line. So I'm going to mark out 1 3/8 off of that. Put a 15-degree bend in here and see how well that fits. And if we can revive this tube, cool. If not, I've just got to toss it and we'll start over with a fresh piece and a new bend. So let's try that out real quick though. Okay, so we're all set up in the bender. Take a spare piece of tube, we'll place it in the notch. Kind of see where you're at here, okay? Now the reason why I do this is I can figure out which direction I want my bend to go. The way I have it set up in the bender here, if the tube runs through this plane or this area, the bend is actually going to go forward. And I don't want the bend to point forward, I want it to go upward. I want it to, you know, bend around the mirror and go point it up toward the roof line a little bit. So I'm just going to clock this right about where I think it's going to end up. We'll crank that down. Now this isn't much of a bend. Actually, I think I'm gonna start out. I'm gonna start out 10, maybe 15 degrees. Just a couple of little cranks here. There's 10. One for good measure there. Let's see how well that fits. So let's see. You know what, 10 fits surprisingly well, but you know what, I think I'm gonna go one more. I'm gonna go to 15 degrees just to kind of really sneak it up there. I'd rather be more out of the way than in the way. So just, I'm gonna stick it back in the bender. I'm gonna give it 15 degrees. Let's see how well 15 fits. That's a lot better. That's definitely a lot better. So the notches don't quite fit right now. I just got to do a little more trimming and open them up just a little bit more so I get that nice tight fit. So I'm going to do that real quick and then we're going to weld this one in. Well, we're progressing quite nicely here actually. Obviously the main hoop is in, front hoops are in, the windshield bar, we got lucky and didn't have to waste any material on that. And as if you'll notice, as we progress, everything's getting just a little bit easier each time. Now I haven't dropped the cage again to get the windshield bar completely welded up top because we have one more piece that we have to do, which is by request. Now it's not in the rule book that it's mandatory for this class, but it is allowed to be added. Any additional reinforcement is allowed to be added, and that's what we're going to do, and that's how it's classified. This piece is called a roof bar, and the purpose of the roof bar is to extend above the driver's head to the opposite corner of the vehicle, or above right where the windshield bar meets, and it's to protect the driver's head in the event that you flip the car over on its noggin. And I usually just jokingly refer to it as a noggin bar, or when I'm talking about it. So if you ever hear me say that, hey, well, there you go. You know it's the roof bar. So I'm going to try and repurpose another tube that I goofed on earlier. It has a 20-degree bend in it, and it stretches over quite nicely. I'm I'm just going to hold it up there and kind of look at it and see, okay, maybe we have enough space without contacting the roof. So I'm going to go ahead and mark it, notch it, and see if I can get it in there. So if we can't, then, you know, hey, bummer. I'll just have to go cut a new piece and give it just a little bit less of a bend, because it does look pretty close where it's at. So to start this off, I'm going to place it up where it needs to be. A rough idea where it's at. It's kind of difficult here, but we get my face line on it. Drop a couple throat lines. Now, the angle that this sits at is actually kind of tricky, so I'm going to go extremely easy on the notching to begin with, because most of it's going to have to get cut out with a grinder. So this notch is going to be pretty straightforward, but this one is right in the middle of that bend radius, so that is going to have to be cut entirely out by hand with the use of a grinder. So I'm going to get this one started out here, see how close we get, and then we'll toss the other one in. Okay, so what I didn't mention earlier, in fact I completely spaced me, but we're also adding corner gussets to the inside structure of the cage in 4 different places, and up inside this corner here is one of those places. So I do have the noggin bar all set up. It's notched out, fits beautifully right in the corner, which it took some time to get because it's a very difficult notch to do. We have it meeting at 2 different places on 2 different heights and also with the radius in the middle of it. So it did take a lot of carving with the grinder and a lot of repeated fit checks in here. So in addition to that, I have the corner gusset already placed in. The noggin bar is going to go straight to the corner gusset. I also have to put the corner gusset on the other side, which I'm about ready to go cut that in a minute here, and then make sure that all of these two made up correctly and meet where they're supposed to and whatnot. So, but it fits. We have clearance on the roof, no problems, no points of contact, so we're pretty much good to go. I'm going to set this in here and give it a good thunk real quick to make sure that it stays in place while I'm doing the fab work and mock up on the other side. So, but as soon as I get the other gusset in, I'm going to drop the cage down again, get all of this welded up, and the front section is pretty much done aside from the door bars. But after we have one more item that needs to go in here before we drop the cage for the final time and get the rocker boxes built, and that is the corner gussets. So we already put the other 2 up top, and these ones are going to go on this side. So we did drop it down to 1.25" tubing instead of using the 1.5", which is no big deal. But one thing you need to remember when you do weld these in here is accessibility. So the cage does have to drop one more time, and where it's going to drop up top here is going to be right in this opening right here. So we'll be able to actually access those to weld them completely all the way around, and of course this one will be accessible through the back door. So as long as when you're fabricating that, you need to know and remember that you have to be able to access it with the welder and whatnot. Otherwise, you know, you could put it up there and find out you can't weld it. So right now I have it mocked up. I've measured from the main hoop to the end of this tube to make sure that it's going to be the exact same on both sides. Both corner gussets are cut identical, and of course slapping them in should be no big deal. So I measured from the main hoop to the end of this, and I got 7 inches. So on the opposite side I'm going to do the exact same thing. So for right now, let's just toss the tacks in. Okay. Now I'm going to tack up the other side, make sure everything looks good, and then we'll do a full weld, drop the cage for the last time. Alright, so I got the noggin bar, windshield bar, the front hoops, and the corner gussets completely welded up now, and the cage is back up on the blocks. I'm going to wait until the fit check later on tonight to actually fix the position of the roll cage and make sure everything is good up front before I start fabricating the rocker boxes. So it's just back up on the blocks again. But in the meantime, while I'm waiting on the fit check to happen later on tonight, I'm going to start cutting and prefabbing everything that needs to go into the back section of the rear of the main hoop. So just because it's a race car doesn't mean it has to look like crap. The idea here is we want to get the rear tubes to mount up to the strut bars, or to the strut towers themselves, to get some plating and whatnot. So this section right here needs to get cut out. Now you can just, take a grinder or whatever the case is, just, cut that out or whatever, but I'm going to use my 3-inch hole saw to make a couple of cuts here to kind of make a nice trim radius, almost kind of make it look factory, and then we'll cut that out with the grinder. Alright, I'm going to have to end up chasing all this down with a file anyway to get some of these little burrs out of here, but that pretty much gives us access to the top of the strut tower. So after this, I'm going to plate this according to the rules, and the rear tube is going to run from the top of the main hoop down here to the strut tower, and the same thing's going to happen on the other side. So I'm going to get that side cut out real quick, and then we'll start plating this up and getting it ready and prepped for getting the main tubes in. Okay, so now it's time to do the mounting points, or the mounting plates, for the strut towers for the rear bar. So we'll go over all the dimensions and everything like that in just a moment, but I'm going to show you right now how I usually mock these up, because I'm going to make this plate start up here in the corner and go all the way around here, because I want to weld another bar in, quite possibly to the strut tower itself. Plus we do have the minimum dimensions we have to meet when it comes to mounting these. So to get these mounted up, I just use a piece of tape here, because this is on a clever radius, and I'll tape it all the way, pretty much all the way down to everything that I've cut off on it. All the areas where I just took off paint and prepped. Now I'm going to grab a marker real quick. I'm just going to kind of trace this design out here that I've got going on. That includes in the back portion of it as well, right about where it needs to stop. That ought to do it. So now I'm just going to take a razor blade and cut this out. Now this isn't extremely specific really about the size. Like I said, we'll go over that in just a moment. But now that it's all cut out, I can peel the tape back to reveal the design. And now this design I'm going to go transfer onto a piece of flat stock that meets the specification and dimensions per the rules. And there's a rough shape. Very, very rough shape, but this will do. Okay, so I'm just transferring my template here onto a piece of flat stock. So let's go over the rules real quick. 4.6.14 mounting plates in the GTA CCR rulebooks states specifically, each mounting plate should be no greater than 100 square inches and no less than 9 square inches. Each mounting plate must be no greater than 12 inches or any less than 2 inches on any side. Welded mounting plates shall be at least 80 thousandths thick, Plates may extend on the vertical sections of the structure. Any mounting plate may be multi-angled, but shall not exceed 100 square inches total, including vertical sections. So simply put, no less than 9 square inches. That's basically down to a 3-inch by 3-inch plate. Okay, we're actually much more than that. No less than 2 inches on any side. So any point that's cut on here may be no less than 2 inches in any measurable point. Okay, so that includes this diagonal section here, which if you measure across here, it's about 4 1/4 inches, so we're good. This plate is 3 inches wide, and the section I need to cut out here is about 8 inches long. So we're definitely good. We have lots of space. So with the template transferred over here, I'm just going to kind of square some of these off. Make some marks here. Just to kind of get an idea of how I'm going to cut it. Now it's going to be kind of a pain to wrap it around that strut tower, but there's a secret to doing that as well. So this section here might have to be trimmed out. So I'm going to mark this and make sure that this still complies with the rules. No less than 2 inches, so we're at 2.5, about 2 5/8, probably at the lowest point. So if that needs to be cut out, we're good. So when I take the template off of here, I can see the shape that I need to cut out. So I'm going to start by cutting this section off, cut this off right here, and if I need, I'll end up grinding this out so we can get the contour and match the radius of the strut tower itself. So. The other side should be exactly the same. So I've already cut this plate out to the right size, and I'm just going to trim that piece off of there real quick. So I just took a minute to clean off some of the mill scale on the front of both plates, and that includes running around the edges because I'd like a nice, clean, crisp weld. Even took a little off the back side so it's less likely to contaminate. So we're going to go toss this in the car real quick and see how close we are and how well I can get this mounted up. Might throw some welds on the first try too, so let's go see how they fit. Okay, the angle looks pretty good, and I'm just going to kind of play along with this real quick and see how well we're actually going to get it to run around that corner there. So it's most likely going to take some hammer modding, or a little persuasion, if you will, to get it on there. But since the top side is a little less accessible than the bottom side for the hammer, I'm going to make sure that I tack down the bottom side first, just to make sure that it can easily be persuaded in there. There we go. So we got a couple holding it in. Let's see if we can get it to round itself up. Can't leave humongous gaps here, so I'm going to just keep on tacking as I go along here, and eventually we'll get all the way around to the other side. Well, he did have a really nice bolt-on strut bar in there. I'm going to go for a little bit more of a permanent solution here. Now, to save weight just a little bit, I did drop the wall size down and go with a 0.95 wall. Still 1.5-inch tubing. So I want a pretty tight fit here. Well, I cut it very, very close. And I'm just going to take a couple measurements here. Alright, looks like we're pretty close. I'm going to go ahead and weld that one in. we'll be good to go to start doing the rear tubes and get the rocker boxes fabricated. Now it's time to make the rocker boxes. So to recap on the rules, they said no greater than 100 square inches, no less than 9 square inches. So any measurement can be no less than 2 inches on each side and no greater than 12 inches on any side, and they can extend on the vertical surfaces. So that means we can build rocker boxes. So I don't want to just meet the bare minimum because sometimes a tech might, they could eventually override anything that you do. If it's right at 2 inches and they say it's at 1.99 inches, they're not going to let it run if they want to be that way. So just to make sure that we have lots of space here, I'm going to go try and measure it and give enough area for the cage to sit on in any given spot. I don't want it too close to any edge, and I don't want it falling off of an edge or anything like that, or looking like it's close to it. So first I'm going to take a measurement here and see how far out we're sitting at. And I've already measured that side and it measures out exactly the same, but the outside of the tube from the rocker measures right at 2 inches. So I'm going to actually go at 2.5 inches for the top plane of the rocker box. And at the 2.5 inch mark, I need to know my height. So at 2.5 inches, I have roughly a 4 3/4 inch, maybe 4.5, possibly 5. So I'm going to go with a 7.5 inch length of steel for the rocker box, put a break on it at 2.5 inches, and then we'll fill in the sides. So I'm going to start by cutting out 2 pieces at 7.5 inches long, and that'll service the 2 rear rocker boxes. Alright, with those measurements in hand, I already have a piece of flat stock here. It's an 1/8 inch thick, which is more than enough. It's 3 inches wide. This is the same stuff we use for the back side on the plating for the rear bars on the strut towers. So said this piece is 16 inches long, so it's actually more than enough to service both sides. So I'm going to make my first mark at 7.5 inches, and I'm going to measure from the opposite side just to make life a little bit easier. I'm pretty much just going to cut out the center section of it and then fit it all up. I did say I wanted the break at 2.5 inches, so the 2.5 on both sides, and then I'll take my square and just give myself some reference lines here. First one was the break line, that's a cut line, that's a cut line, that's a break line. So once this gets folded over, this top section here is where the roll cage will mount, and the center section here is going to be the vertical plane from the floor, which is the center section there is where it's going to be attached to. Now, in the interest of saving weight, we're going to add a hole here and dimple die it a little bit later on here. So I'm just going to mark out where the center of that plane is going to land. I'll just do that by putting an X from one corner to the other corner. Very easy to do. Now we're going to pop 2 holes here at 1 1/4 and then dimple die those after we cut and break the metal over to give it that nice even fold. So I'm going to go cut this out right now. We'll pop the break in it. We can toss the holes in at any time, and then eventually we'll run over to the press and stick it in for the dimple die. So not every shop or not every person or fabricator or whatever the case is is really graced with having a shop that's outfitted with a nice big press brake to make a nice even bend in some 1/8 inch steel. So we're going to use the best thing we have, or the best thing I've got. You can find it in most fabrication shops, but you crank down this plate of steel at the mark where it needs to go, grab yourself a big hammer, or what we call a BFH. And you want that to be at about 90 degrees, as evenly as possible. Now you will get some hammer marks in it, and that's totally normal. You just take a flat disc or something to grind it nice and smooth with. And as soon as you're done, you have a nice, evenly bent plate. So you do both pieces, and sooner or later you have rocker boxes. For those of you that are not familiar with the concept of dimple dies, I'll give a brief explanation for you. Basically, the purpose is to cut a hole, and when you cut a hole, you're actually making it lightweight. Now, one single hole like this doesn't do a whole heck of a lot, but multiple holes will. So the more holes you have, the less weight that your material is going to be, but the weaker it then becomes. So the purpose of the dimple die is you can see that there is a beveled raised edge on this side and a beveled recessed edge on this end. When you place both of them together inside of a press and smash these two together, you'll either get a recessed bevel or a raised bevel, depending on which end you look at it. So what that does is strengthens up the edges of it around the areas that you cut. So around the areas that this is, where this would actually be very easy to bend right now, with a bevel on it, it would be very difficult to bend. So what you end up with is a lighter weight piece that is also just as strong as if you didn't cut a hole in it to begin with. So that's the whole purpose of using dimple dies. Plus, everybody's a sucker for them. They look great. So you can actually use them aesthetically as well as functionally to lighten up your chassis and remain the same strength as it was before. So now that we have the pieces cut, we're going to run across town and borrow a press because I'm currently without one. We're going to pop some dimples in these holes. So let's get to it. Okay, so I've already taken the moment here to clean up the sheet metal and get the seam sealer out of the way. Now, if you're not familiar with the easy way of doing that, go ahead and check out my other video, which you'll find the link in the comments below. So, got all the metal prepped, got it ready. So I'm going to stick the rocker box up here, and kind of notice it's just a little bit too long at the bottom there. So I'm going to have to trim this down a little bit because I'd like it to get a little closer to the rocker and get the top of the rocker box just a little bit more level. Because this just, it's kind of sitting a little crooked, and I think that's, I just don't want to let that slide. That looks kind of terrible. So I'm going to get this cleaned up. This bottom section here with the grinder is going to get trimmed back a little bit so it mates up better with this section here. That's a much better fit. So what I'm going to do is grab the welder real quick, throw a couple of tacks down on it, and hopefully we'll be good to go. I'm just going to tack the bottom there to get a nice snug fit until we get all four corners done, and then we'll go back and weld everything else together. This is just in case I need to pull them back, remove them, shift them around, whatever the case is, while we're fabbing up the rest of them. So got one down, let's go get the other ones done, and then we'll start making the sides and box these completely in, and then the cage is pretty much set in place. Alright, so all four corners of the rocker boxes have been tacked in place, and we should be good to go on that one, but we'll go back and actually fully box them in and fully weld them later on. For right now, I'm going to get the cage measured up and set in place, and we're going to get all 4 corners tacked to the rocker boxes themselves. After that, I'm going to start fabricating the rear bars and the diagonal brace that goes in the back. That was also an additional request. So I'm going to get this measured up real quick. We're going to drop some tacks onto the top of the rocker boxes, and then we'll get back to fabricating the rear section.